Good evening.
Okay, everyone, let's continue our topic now. Any question from previous session, everyone? Akash, any question from previous session?
No.
Okay. So we complete our source NAT discussion. Okay, I told you in firewall scenario. In firewall scenario, we can go with two type of NAT implementation. The first one is source NAT, static, dynamic, and PAT. These are the examples for source NAT implementation. Now, what about destination NAT? What is the scenario to use destination NAT? Okay, so let's create a scenario. Wait. For destination NAT, okay, wait. So I have a firewall device, for example. I have firewall device and this portion, I'm using as a DMZ side network, DMZ side portion. In DMZ side network, I have multiple servers, for example, multiple servers like web server, SMTP server, DNS server, NFTP server. This portion is what? DMZ network. Now this side I'm using as a ISP side portion. ISP side portion. So this is fast Ethernet 0/0. This is public facing interface. We are using 99.99.99.100, for example. Okay, so this one is a web server, company web server. IP address I'm using 192.168.10.10. This one is a DNS server. IP address 192.168.10.11. SMTP server, simple mail transfer protocol 192.168.10.12. And this one we are using as a FTP server. Wes, can you hear me? Wes, can you hear me?
Yeah,
Now,
I can.
okay. 192.168.10.30. Now into this design, we can go with PAT configuration. If you guys remember PAT concept, we can implement here PAT, port address translation. We can implement PAT. With PAT, what we can do, we can translate multiple private IP address. We can translate multiple private IP address with single public IP. For example, if 10.10 is trying to travel outside, this IP can translate with this 99.99.99.100 and traffic is traveling. 10.11 is getting same IP and traffic is traveling. So into this design, into the scenario, yes, I can implement PAT option, no problem. I can implement PAT. If traffic is initiated, traffic is initiated from inside network, from your private network, then yes, you can go with PAT option. But this time our task is changed. Okay, this time traffic is not initiated from inside network. This time traffic is coming from outside network. Traffic is initiated from outside network. My point is, if this outside machine will hit on this public IP, then how your firewall will identify if traffic is going to hit on firewall device, hit on this public interface, public facing IP, how your firewall will identify, okay, this traffic is for web server, or this traffic is for DNS, or it is for SMTP, or it is for FTP, how your firewall will identify. Clear this challenge, everyone? Problem? And we have a solution. We have a solution for this problem. We can, into this scenario, if traffic is initiated from outside, into this scenario, I can go with static NAT. I can go with static NAT implementation. What is static NAT? Remember static NAT? In static NAT, we can go with one-to-one mapping. We have 4 servers in inside network. So yes, I can buy 4 public IP, 99.99.99.150, 150, 151, 152, 153. I can buy 4 public IP because I have 4 private servers. In LAN side, I have 4 IPs. That's why I'm going with the 4 public IP. With the static NAT, yes, I can map this public IP address. I can map this public IP. For example, this 199.99.99.150, I can map with this 192.168.10.10 because it's a static NAT configuration. 151, I can map with this 10.11, 152, 10.12, 153, 10.13. If you guys remember, static NAT is bidirectional. If 10.10 is trying to travel outside, okay, if 10.10 is trying to travel outside, okay, it will get this public IP and traffic is traveling to outside. Or if anyone from outside will hit on this public IP address, as per static NAT configuration, this traffic, this public IP is mapped with this private IP address. So your firewall will redirect this traffic on 192.168.10.10. So you can use static NAT configuration method here. No problem. If I have 2 or 3 servers, then yes, I can go with the static NAT option. I can use static NAT, but in case if I have multiple servers, for example, I have 20 servers, I have 25 servers, then if I'm going with static NAT configuration, I need to buy 20 to 25 public IP. Then what about cost? I need to go with 20 to 25 public IP address. This is the issue. That's why I'm not using static NAT into the scenario. I'm not using static NAT. I can go with the static NAT. It's a bidirectional, but I'm not going with the static NAT because if I have 20, 25 servers in LAN side network, then I need to buy 20 public IP. 20 public IP. That's why we are going with DNAT configuration. We are going with destination NAT implementation. What is destination NAT? In destination NAT, we need single public IP. In destination NAT, we need single public IP. For example, I have 99.99.99.100, for example. Sorry, 100 we are using on this interface, 155 or 155. So I need single public IP. In destination NAT, I need single public IP. If you guys remember PAT option, in PAT, we need single public IP, remember? In PAT, we need single public IP. In destination NAT, we need single public IP. Then what is the difference? What is the difference in between PAT and DNAT? So if you guys remember PAT discussion, our PAT discussion in PAT, we can translate. In PAT, we can translate multiple private IP address with single public IP. We can translate. But in DNAT, what we can do? In DNAT, we can map. In DNAT, we can map multiple servers. We can map multiple servers with single public IP. Multiple servers with single public IP, okay? This one is a web server. How you can say this 192.168 is a web server? Because we are using port number 443 here. This one is a DNS server because port number 53 is open. This one is a mail server, SMTP, port number 25 is open. This one is FTP server because FTP service we are using. So FTP role we are using with 192.168.10.13. FTP port number is 21. So in DNAT, what we can do? In DNAT, we can map multiple servers with single public IP. With single public IP. Everyone, can you hear me? Akash, Divyanshu, Dushyant,
Yes, I
Arshal,
can.
Moin.
Yes. Yeah.
So in DNAT, we can map multiple servers with single public IP. Now, how to configure DNAT? I will show you in practical implementation. But let's finish our story, the concept. So now this time, if anyone from outside, my point is this time, if anyone from outside will hit on this public IP, and if this request is for port number 443, then as per DNAT configuration, your firewall your firewall will redirect this traffic on web server. If anyone from outside will hit on same public IP, because I have single public IP. If anyone from outside will hit on this public IP address, and if this request is for port number 53. So as per your DNAT configuration, your firewall will redirect this traffic on DNS server. If anyone from outside will hit on same public IP, if this request is for port number 25, request is for port number 21. So as per DNAT configuration, your firewall will redirect this traffic on SMTP, and this traffic is on FTP. Clear this point, everyone?
Yeah.
Now again, okay, into the scenario we have a issue. Into the scenario we have a issue. If I have multiple web server, then if I have multiple web server, if I have multiple FTP server, if I have multiple web server or FTP server, for example. Okay, for example, here we have, wait. We have web server 1, web server 2, for example, or we have multiple FTP server. This is FTP server 2, FTP server 1, FTP server 2, IP address 192.168.10.14, port number 21. So if I have multiple web server, multiple FTP server, then as per your configuration, your port number 21, is already mapped with this FTP server 1, this public IP, and this port 21 is already mapped with this 192.168.10.13 port number 21. It's already mapped. Now, what about FTP2? What about FTP2? Because outside user, for example, this user, what he can do, he can open his FTP application. He can put this public IP address information in FTP software, and standard port number for FTP is port number 21. So port number 21. If anyone from outside will hit on this public IP, and if this request is for port number 21, as per your DNAT configuration, your firewall will redirect this traffic on 192.168.10.13, port number 21, as per your DNAT mapping. Now, what about FTP2? Because port number 21 is already mapped with this 10.13 IP. Then what about FTP2? So into this scenario, you can use a concept is called DNAT with port forwarding. You can use a concept is called what? DNAT with port forwarding. DNAT with port forwarding. It's a common concept. You can use this concept in any firewall device. So into this scenario, we can go with DNAT with port forwarding concept. What I can do, I can use any unregistered port number. For example, I'm using 8999. So what I can do, I can map this public IP, and this port number with 192.168.10.14, port number 21. But this is not a standard port number for FTP service, right, everyone? This is not a standard port number for FTP, right? Yes or no, everyone? This is not a standard port number, 8999. So what you can do into the scenario, you can tell to your outside user, guys, whenever you will hit on this public IP, for FTP service, please use port number 8999. Your outside user, they don't care anything. They don't know, okay, this traffic will redirect on FTP1 or it will redirect on FTP2. They don't know anything. What they can do? Your outside users, what they can do, they can just open FTP application, their FTP applications. They can put this public IP address information here. And in FTP application, they are using port number 8999. As per your configuration, as per your DNAT with port forwarding mapping, if anyone from outside will hit on this public IP for FTP service, this public IP with port number 8999, as per your DNAT and port forwarding configuration, your firewall will redirect this traffic on FTP2. And this is not just a story, okay? You can do practical implementation. I will show you how to do port forwarding. Is it clear, this NAT theoretical concept?
Yes.
Yeah.
Okay, now let's go for implementation. So we have designed, give me 5 minutes, everyone, okay? I'm preparing design here. Okay, wait. Okay, please wait 5 minutes. I'm preparing this design.
Okay.
It's the same topology. For basic connectivity, I'm using static and default routing configuration. This is inside router. Host name, I'm using inside interface. Ethernet 0/0, IP address 200.200.200.10, mask, no shutdown. We can create loopback interface here, 1.1.1.1, mask. Now show IP interface brief, and I'm configuring default routing for any unknown destination. 200.200.1 is the next hop IP. Let's go to DMZ router. Host name is a DMZ router, interface Ethernet 0/0, 10.1.32.10, mask, no shutdown. Now we can create a loopback interface 2.2.2.2, mask, show IP interface brief for any unknown destination. 10.1.32.1 is the next hop IP. Let's go to outside router. Host name, I'm using outside interface Ethernet 0/0 as per design. 10.1.23.10 IP I'm using. No shutdown. Interface loopback 0. 3.3.3.3 mask. Show IP interface brief. Now, for any unknown destination, let's create a default route towards firewall box. For any unknown destination, 10.1.23.1 is the next hop IP. Let's go to the firewall box. Okay, please wait. Firewall is taking time. Please wait. Please wait, everyone. Okay, 5 minutes. I'm restarting rank. Okay, let's start our configuration again. OS, Moin, Harshal, Dushyant, Devanshu, Akash, everyone can hear me? Nitesh. Okay.
Yeah.
Yes.
Now host name inside router. Please wait 5 minutes. 200.10. Mask, no shutdown. Interface loopback 0. 1.1.1.1. Now show IP interface brief. Hostname DMG, interface Ethernet 0/0, 10.1.32.10 mask, no shutdown, interface loopback 0, 2.2.2.2 mask. Now show IP interface brief. Host name outside, interface Ethernet 0/0, 10.1.23.10 mask, no shutdown, interface loopback 0, 3.3.3 for any unknown destination. 23.1 is the next hop IP. Let's go to forward box now. Wait. Everyone, can you hear me? Please wait, okay? Okay, it's working now. Akash, Devanshu, Dushyant, Harshal, Moin, Naveen, Wes, everyone can hear me?
Yes, we can hear you.
Yes,
Now
we
it's
can.
Yeah.
working.
Yep.
Let's start our configuration. Wait. Interface Ethernet 0, name if inside IP address 200.200.200.1. This is inside interface. No shutdown. Interface Ethernet 1, we are using as a outside interface 10.1.23.1 mask. No shutdown. Interface Ethernet 2, we are using as a DMG network. Security level, I'm using 50. IP address 10.1.32.1 mask. No shutdown. Root inside, we have a loopback interface 1.1.1.1 mask. Next hop IP dot 10. Root DMJ 2.2.2 mask 10.1.32.10. And for outside network, I'm using default routing for basic connectivity 10.1.23.10. Now let's go to router. Let's go to router. Host name inside 200.200.10 mask. No shutdown. Loopback interface 1.1.1.1 mask. Show IP interface brief. For any unknown destination 200.200.200.1 is the next hop IP. Let's go to the DMG router. Now host name DMG interface Ethernet 0/0 and 10.1.32.32.10 mask. No shutdown. Interface loopback 0 2.2.2.2.2 loopback. Now IP route for any network, any mask 10.1.32.1 is the next hop IP. Let's go to outside router. Host name outside interface Ethernet. Okay, it's a 0/1 interface Ethernet 0/1. Let me check inside router interface. Okay, it's a Ethernet 0/1. Wait. No IP address. Ethernet 0/1. 200.200.10 mask. No shutdown. Show IP interface brief. Let's go to Ethernet 0/1 outside router, IP address 10.1.23.10. No shutdown. We can create loopback interface here. 3.3.3.3 mask. Now show IP interface brief. Now let's go for NAT implementation we want. And here we can focus on static NAT, dynamic NAT, PAT option, and then DNAT implementation. Destination NAT implementation. This is our topic. Let's go to the firewall device. We can verify our basic connectivity. Ping 1.1. Yes, we have a reachability. 2.2.2. Ping 3.3.3. We have a reachability. And in case, if I'm trying to initiate my traffic from inside network, I'm trying to travel outside router, outside network, line VTY 024, password CISCO 123, login, transport, import, telnet. So from inside network, I'm trying to initiate my traffic. I'm trying to access telnet traffic 10.1.23.10. Wait. Show IP interface brief. Show IP route. Okay, wait. I need to configure default routing for any unknown destination. 10.1.23.1 is the next hop IP. Now we can try password CISCO 123. It's working. Can we start our NAT configuration, everyone? Akash, Divyanshu, Dushyant, Harshal.
Okay.
Okay, let's start our NAT configuration here. So let's go to the firewall box. So I'm trying to configure dynamic NAT first. Remember dynamic NAT? In dynamic NAT, we can create a range of public IP. We can create a range of public IP addresses here. For example, I have a range of public IP 10.1.23.52, 10.1.23.55. So I have 6 public IP. Okay, I have 6 public IP. It means any 6 machine from inside network, any 6 machine can utilize this public IP range. Let's try to configure dynamic NAT. Dynamic NAT here. Let's go to the CISCO ASA firewall box. And what is command syntax for NAT implementation here? What is command syntax? Object is a command. Object network is a command for NAT configuration. Object network is a command. Now, question mark. You can give a name for this object. So CISCO ASA, FTD, Palo Alto, checkpoint. These are called object-oriented firewall. So in these firewall devices, we can create object here, and these objects we can use in our configuration. So I'm creating object here. You can give a name for this object. For example, pool 1. Just a name, just object name, pool 1. So we are in object. If you type question mark, we can create single IP address object. We can go with range of IP object. We can go with subnet object. We can also configure NAT here. In object, we can configure NAT. So right now I'm trying to configure dynamic NAT, and I have range of public IP address 10.1.23.50 to 55. I have range of public IP address here. So I'm using range command. You need to define your start IP address information. So start IP 10.1.23.50. Question mark. You need to define enter IP address, enter end IP address. So 10.1.23.55. So I have 6 public IP. So any 6 machine can utilize this public IP range. You can press enter. And now into this object, see what we have. Wait, we have an object name. We have object name pool1. Let me show you. Exit. Show run object command you can use to verify your object information. So we have one object, pool1. And into this object, we have range of public IP. Now I'm creating one more object. Command is what? Object network. You can give any name here. For example, I'm giving inside network. INS, inside network. You can type anything, no problem. You can press enter. Into this object, I'm using subnet command. I want to define inside network IP address information. So I'm using subnet command. Subnet is what? 200.200.200.0. This subnet will utilize this public IP range. So subnet mask is 255.255.255.0. You can press enter. And into this object, you can define your translation entry. You can create your translation entry. So for translation entry, you can use a command NAT. NAT. So command syntax is what? NAT. You need to define traffic flow here. Traffic flow. As per our task, traffic is initiated from inside network. Traffic is traveling from inside to outside. This is our direction. As per our task right now, traffic is traveling from inside network to outside network. So here in bracket, we can define it. In bracket, we can define our traffic flow information. So traffic flow information, traffic is initiated from inside network. This is what? Source information. Traffic is initiated from inside network, comma, traffic is traveling to outside network. This is our direction. NAT, inside to outside. Traffic is initiated from inside, trying to go into outside. In case, if trying to travel outside, then I want to apply IP pool. So you can use a command dynamic, and yes, we can define our pool information. So our pool name is what? Pool name, we are using pool1. So when traffic is traveling from inside to outside, if this subnet is trying to travel inside to outside, I want to apply NAT here, and I want to apply pool range here. So pool range name is what? Pool1. Done. Our dynamic NAT configuration. If you verify, show run object command you can use. Show run object. So we have two objects, pool1 and inside network object. If you want to verify traffic flow, show run NAT command you can use to verify your traffic flow. Traffic is traveling from inside to outside. Then I want to apply this pool range. Clear this command syntax? Akash, Divyanshu, Dushyant, Harshal, Moin.
Yeah.
Yep. So
Now, you can initiate your traffic, no problem. You can initiate your traffic from inside network, but before initiate your traffic, let's verify translation entry. In firewall device, in Cisco router, you can use a command show IP NAT translation. But in Cisco ASA firewall device, to verify translation information, you can use show xlate. Show xlate command you can use to verify your translation information. Right now, we don't have any entry. Let's initiate some traffic from inside router. I'm trying to access 10.1.23.10. I can access, no problem, because traffic is traveling from a higher security level to lower security level. So traffic is traveling, no problem. But this time our focus is on translation. Translation has happened or not. So I'm trying to access 10.1.23.10. Traffic is traveling from higher security level to lower security level, and this is TCP traffic. I'm trying to access password is what? Cisco 123. I can access it. Cisco 123. Yes, I can access. Traffic is traveling through the firewall device. Traffic is traveling from higher security level to lower security level by default. But our focus is on translation, translation verification. So we can use a command show xlate. So you can see now traffic is initiated from inside network 200.200.200.10, and this IP is translated with 10.1.23.51. Remember our range, everyone? 50 to 55. Dushyant?
Yeah, it's from 50 to 55.
Yes, we have a range 50 to 55.
55.
So this machine is getting one IP address from this range 10.1.23.51. Clear this verification, everyone? Clear this verification?
Yes.
Okay, can we take a
Yes.
break for 9 minutes?
Okay.
So,
9 minutes break, okay? It's a 6:56 on my side.
Natural.
We will continue at 7:05, okay? Please turn off your mic. Harshal, any question?
Yeah, I do have one query.
Mm-hmm.
So in the natural, we didn't define the inside subnet. So it will like just considering the interface.
If you remember our configuration, so yes, we have a subnet information. This complete subnet. If this
Right.
complete subnet is trying to travel outside from inside to outside, we applied our pool information here.
Okay, but in the natural, like we define the pool one.
Yes, pool one. In pool one, we have a public IP range 10.1.23.50 to 55. So this inside machine 200.200.200.10 is getting IP address from your pool range
Okay, so
10.1.23.51.
so we no need to define this inside subnet in the natural.
Inside subnet
Yeah.
in NAT. See, yes, wait. See it. In our object, we have a subnet information. Let me show you again this configuration. We have this object, Harshal, okay? Into this object, we have subnet information. And in same object, I'm using my translation configuration. See, in same object, I'm using my translation config object network inside subnet information and translation entry. You can create two objects here. First object is a pool object where you can define your public range information herself. Clear? This line.
Okay.
Second object you can create, and into this object you can define your LAN subnet information. You can define your translation entry. So again, we have a same, see, object network inside. Into this object, yes, I have LAN subnet information. And now into this object, I'm telling if traffic is traveling. I'm creating my translation entry. If traffic is traveling from inside to outside, this is direction. Traffic is traveling from inside to outside. If traffic is traveling from outside to inside, I will define outside, comma, inside.
Okay.
Traffic is traveling inside to outside, then I applied this pool range. And what we have in pool one, we have 10.1.23.50 to 55. Clear this point?
Yes.
So you can verify show xlate information here. We have a translation entry 200.200.10 is trying to travel outside, is getting this range IP information. This range 10.1.23.51 is getting IP address from your range. Clear now, Harshal?
Yeah. Yes.
Okay. Okay, everyone, let's take a break for 10 minutes. Okay. We will continue at 7:10. Everyone, can you hear me?
Okay.
Hi everyone, can you hear me?
Hello.
Everyone, can you hear me? Okay, let's continue our topic now. Okay, let's go. Wait. Let's go for static NAT implementation. Okay, before static NAT, let's start our verification again. So I'm trying to initiate my traffic again. Okay, wait. Telnet 10.1.23.10. Traffic is traveling through the firewall device. You can verify now. Traffic is traveling through the firewall device. And if traffic is traveling through the firewall device, I can verify translation information. So you can see this machine is getting same IP again, 10.1.23.51. So if you verify session table information or connection table information, show connection table. So yes, 200, 200, 200, 10. This is source IP, source port number, destination IP, and destination port number. So here we have translation entry. This one is what? Translation entry. This entry will be available for 3 hours. If you go with the exit command, if inside machine, exit, terminate his session, telnet session, and if you verify on firewall, if you verify your translation information, so this entry is available for 3 hours. Firewall will maintain this entry for 3 hours. If you want to delete this entry, no problem. You can go with the command clear xlate. Clear xlate command you can use to delete this entry. Show xlate command you can use. Now we don't have any entry this time. In case if you want to change this timeout, so you can go in global configuration mode. You can go in global configuration mode and you can use a command timeout xlate and question mark. You can define your timer. For example, 0 hour, 30 minute, 0 second. Now, if I'm initiating my traffic again, I'm trying to access 10.1.23.10 from inside router. Let's initiate our traffic, CISCO 123. So traffic is traveling through the firewall box. And in case if you want to verify your translation entry, your translation information, show xlate command you can use. And yes, you can see this machine is getting a new IP address, 10.1.23.54. This machine is getting a new IP address from your pool range, and timeout is now changed. Firewall will maintain this translation information for 30 minutes. Now let's go with the exit option. Now this design we can verify in a real network. Akash, Divyanshu, Dushyant, Harsal, Moin,
Okay.
Nitish.
Yes.
This design we can verify in a real network. Okay, let's create a real topology. I have a design. Okay, it's taking time. I will show you later. Okay, wait. Let's go with this topology now. So now dynamic NAT, I hope this point is clear how to configure dynamic NAT. Can we move for static NAT implementation now? Everyone,
Okay.
static NAT implementation. What is static NAT? In a static NAT, we can go with one-to-one translation entry. One-to-one translation entry. For example, in DMZ side network, we have multiple servers like web server. IP address is 10.1.32.15. This private IP address I want to map with this public IP 10.1.23.15. I have DNS server 10.1.32.16. This IP I'm trying to map with 10.1.23.16. SFTP server 10.1.32.17. This private IP address I'm trying to map with 10.1.23.17. And for real verification, I could go with router to DMG router IP address, R2 IP address 10.1.32.10. This IP address I'm trying to map with 10.1.23.18. So this is our task. Okay, we have private IP and public IP. We have private IP and public IP information. 32.15, I'm trying to map with this public IP address, 10.1.23.15. 32.16, I want to map with 23.16. 10.1.32.10. This is R2. This is DMG router IP address, 10.1.32.10. This IP address I want to map with 10.1.23.18. Okay, so let's try to configure static NAT now. Let's go to the firewall device. Before configure static NAT, I'm trying to delete this entry, this dynamic NAT configuration. I want to delete. Clear, configure, object command you can use. I'm trying to delete all object information. You can verify now. Show run object. Show run NAT information. So we don't have any object and NAT translation entry. Now this time I'm looking for static NAT implementation, one-to-one translation entry. So let's start our configuration, and I'm trying to create an entry for web server. So we can create object here. What is command? Object network. Object network. You can give any name for this object. So web server. Now into this object, I'm creating single IP address object. So I'm using host command. So what is web server IP address? 10.1.32.15. This is web server IP address. And into this object, I'm creating my translation entry. So for translation, command syntax is NAT. So if traffic is traveling from DMZ to outside, So this time I'm using static command. Command syntax is what? Static. So this web server IP address I'm trying to map with this 10.1.32.23.15 IP as per our task. 23.15. Done our first translation entry. Now you can create your entry for DNS, object, network, DNS, now host, 10.1.32.16. And into this object, I'm creating my translation entry. So NAT, DMZ to outside. If traffic is traveling DMZ to outside, I'm creating static entry, static translation entry. This 10.1.32.16 IP, I'm trying to map with 10.1.23.16. Let's create entry for SMTP server, object network, SMTP, just a name. This SMTP, DNS, or web server. This is object name, everyone. Now host. So 10.1.32.17. Now I can define translation entry here. So NAT, traffic is Traffic is traveling from DMG to outside static. And yes, I have a public IP 23.70. And for real verification, I'm using R2 IP address, DMG router IP address. So object network, DMG, for example, host IP address is 10.1.32.10 we are using. And now NAT DMG to outside static 10.1.23.18. So like this, you can create multiple translation entries statically, manually. You can verify now your object information, show, run. Object command you can use to verify your object information. So we have web server object, DNS server object, SMTP object, DMG object. And if you want to verify your translation, show, run, mat command you can use to verify your translation. So in DMG object, we map this 10.1.32.10 DMG router IP address with 10.1.23.18. So I can initiate my traffic from DMG side network, no problem. I can initiate my traffic from DMG to outside, no problem. Traffic is traveling from higher security level to lower security level, so traffic is allowed. Traffic can travel. Okay, but now what I'm doing, I'm trying to initiate my traffic from outside network. Let's initiate our traffic from outside network, because I told you static NAT is what? Static NAT is bidirectional. Static NAT is bidirectional. So I can try to from outside, I can hit on this public IP 10.1.23.18. This outside machine can hit on 10.1.23.18 IP. And as per your configuration, this 23.18 IP address, it's mapped with this inside DMZ router IP address 10.1.32.10. So as an outside user, I don't know anything about this DMZ router IP. No, I can only hit on public IP. As an outside machine, I can only hit on public IP. So let's go to outside. Let's go to outside. And I'm trying to hit on this public IP. I'm trying to hit on for telnet service. Okay, before I initiate our traffic, let's go to DMG router and I'm trying to enable telnet. Line VTY 024, password CCIE123, login, transport, input, telnet. So I can try to initiate my traffic from outside, and from outside, I can only hit on public IP. From outside, I can only hit on public IP 10.1.23.18. 23.18. But traffic is traveling into the scenario. Traffic is traveling from lower security level to higher security level. So to allow your traffic, this traffic from lower security level to higher security level, we need to configure access list. We need to configure access list here to allow our traffic from lower security level to higher security level. So let's go to the firewall device before initiate this traffic. Let's go to the firewall device and I'm trying to create a access list entry. So access list outside. It's an ACL name, outside permit, TCP, source, any source from outside. Anyone from outside can access host 10.1.32.15 equal to port number 443. With this rule, I'm trying to allow anyone can access web services. Web server 10.1.32.15. Clear my point, everyone? With this ACL entry, I want to allow anyone can access 10.1.32.15 for web services. I can create ACL entry for DNS, for SMTP, for DMG router. So access list 10 permit. Any host can access 10.1.32.16 equal to port number 53. Anyone from outside can access 10.1.32.17 equal to port number 25. And for real verification, I'm trying to allow anyone can access 10.1.32.10 for telnet service. So equal to port number 23. Telnet we can verify. Done our translation, done our access list entry. And once you configure access list, you need to apply this access list on interface. So I can apply this access list on public facing interface. I can apply this ACL on outside interface. So access group command, remember our previous session, access group is a command and we can define our access list name. So outside in interface, and I want to apply on outside interface. Done. I can try to initiate my traffic from outside. From outside, I can only hit on this public IP 10.1.23.18. I can hit on this public IP. I don't know anything about inside DMG router IP address. No. I can only hit on public IP. So telnet 10.1.23.18. This public IP is mapped with this DMG side router 10.1.23.10. Let's initiate our traffic. So we have translation entry, we have access list entry. See, we are getting a page to access telnet service, and password we are using CCIE123. Wait, CCIE. I can access. Clear this lab, everyone. Static NAT implementation. Clear this is static NAT configuration, everyone.
Yes.
Yep.
Now let's go for PAT implementation. What is PAT? Port address translation. We can translate multiple private IP address with single public IP. We can translate multiple private IP address with outgoing interface IP address. Let's try to implement PAT configuration here. Wait. Let's go to firewall device. And I'm trying to delete access list entry, clear configure access list, clear configure object. So I don't have any object. I don't have any access list. So in case, if I'm trying to initiate my traffic this time, again, I don't have any NAT entry. I don't have any access list entry. If I'm trying to initiate my traffic, I cannot access. You can verify now, I cannot access. I cannot access. Let's go to the firewall device. And we are trying to implement PAT option. PAT, port address translation. We can translate multiple private IP address with single public IP. Okay, let me check this. Another rack. I want to show you a real lab here. Wait. Okay, this is internet cloud. This one is an internet cloud. So I have simple topology. I have one firewall device with LAN interface. LAN interface and WAN interface. Into this design, I want to show you a real translation with ACL and NAT rule configuration. This will take time, okay? Let's go to the design. Okay, so here we are trying to implement PAT option, port address translation. So let's go to the firewall device. And for PAT configuration, command syntax is very simple. For PAT configuration, object network is a command. You can give any name for this object. For example, I'm giving PAT. Now subnet. Yes, I have a subnet 200, 200, 200.0. Mask. So object is what? PAT. And subnet is 200, 200, 200.0, our LAN subnet. So if LAN subnet is trying to travel outside, LAN subnet is trying to travel from inside to outside. This time I'm using dynamic command, but I'm not using a dynamic NAT. No. Dynamic if you remember dynamic NAT configuration. So with dynamic command, you can add your pool information, IP address pool information. But this time I'm not configuring dynamic NAT. This time I'm configuring PAT option, port address translation. So with dynamic command, I'm using command syntax interface. Done. Our PAT configuration. If this LAN subnet is trying to travel inside to outside, for translation, I'm trying to apply interface. Interface is what? This is exit interface, everyone. Exit interface. And as per our flow, our exit interface is what? Outside interface. It means I'm trying to translate all LAN subnet IP address with this outgoing interface IP. With this outgoing interface IP. You can press enter. We can verify our translation. We can try to initiate our traffic from inside router. Let's initiate some traffic, telnet 10.1.23.10. And yes, I can access password. Password we are using, I think CISCO, yes, CISCO 123. Now you can verify, show, accelerate. And yes, this 200, 200, 210 is getting okay, this one is an old entry. Okay, this one is an old entry. Dynamic NAT entry. Let's delete this entry. Clear. Accelerate. Let me check configuration. Show run NAT. Dynamic interface. Show interface IP brief. So this one is a pub. Wait. This one, Ethernet one is a public facing interface. This one. So exit, and I'm trying to initiate my wait. Okay, let's initiate our traffic again. So telnet 10.1.23.10. Password CISCO 123, and traffic is traveling. We can verify our translation information. So this inside machine 200, 200, 200.10, this inside machine is translated with this outgoing interface IP. Outgoing interface IP 10.1.23.1. This is outgoing interface IP address. And this is our PAT implementation anymore. PAT implementation. Let's go with this design, okay? I want to show you NAT option in a real network. So this is inside portion and this is outside portion. So for outside, I'm using 192.168 1.0 network in my topology, okay, in my topology. So we can configure this firewall device. We can configure this firewall. Wait. So I'm trying to prepare this firewall box. Show interface IP brief. Interface Ethernet 0. Name if inside IP address 200.200.1 mask. As per our design, Ethernet 1 is a outside interface. So interface Ethernet 1. Name if outside IP address I'm using 192.168.1.150.155. No shutdown. Now I can create a default route for any destination, for any unknown destination. 192.168.1.1 is my gateway. In my design, everyone, in my design, this is my gateway. This is Wi-Fi router IP address. And you can verify now, show IP route. Oh, sorry. Show route information. You can verify for any unknown destination. 1.1 is a gateway. So you can verify ping. I'm trying to verify internet connectivity. I'm trying to ping 8.8.8. See, I have a reachability. I can ping Google DNS 8.8.8. See. So in case if I'm trying to initiate my traffic from LAN side network, LAN side portion, ncpa.cpl. As per our design, I'm using 200 network IP. So 200.200.200.24. Gateway is 200.200.200.1. And DNS in my design, DNS IP is 192.168.1.1 and 8.8.8 is the alternative DNS IP. My point is we have proper IP address configuration on LAN machine. Proper IP address configuration, IP address, mask, gateway, DNS entry. Proper IP address configuration. So in case if I'm trying to initiate my traffic, I'm trying to ping 8.8.8.8. I'm trying to ping 8.8.8. When you initiate this traffic, okay, wait. So I'm trying to initiate ISMP traffic. So if you guys remember, traffic is allowed from higher security level to lower security level, but only TCP and UDP traffic. So I cannot ping, but in case if I'm trying to access google.com, I'm trying to access, for example, facebook.com. When you initiate this traffic will go and hit on firewall device. This is L3 appliance, everyone. So firewall will check his routing table. Okay, you want to go on google.com, facebook.com. Let me check my routing table. Is there any entry available? So yes. Yes, this firewall has a default route towards any unknown destination. This firewall has a default route, but traffic is not traveling. Can anyone help me? Traffic is not traveling. This is a real network. Traffic is not traveling from private network to public network. So we need to configure NAT. Everyone, we need to configure NAT option into this design. Everyone, can you hear me?
Yeah.
We need to configure NAT into this design. We cannot access. So let's go to the firewall device. And for translation, I'm using PAT option. Okay, PAT option. So object, network, you can give any name, PAT1. Subnet, yes, I have 200. Subnet, 200.0 mask. And now if traffic is traveling from inside to outside, I'm trying to apply interface command. I'm trying to configure PAT. Done. We have a NAT configuration. So you can try to initiate your traffic again. Let's try to refresh this page. Refresh this page. Please wait. You can verify now here. Show run interface. Show run object. Show run NAT. So yes, we have proper configuration. Let's wait. Okay, it's working slow. Okay, please wait. Okay, it's working slow. It's a VM machine. Yes, we can access. Inside machine can access google.com. Inside machine can access facebook.com. It's working very slow. Yes, we can access. Now you can verify your translation information. Show xlate command. You can verify. See, you have translation. And as per our task, we are using PAT option. So this 200.224 is translated with this outgoing interface IP 192.168.1.155. Yes, you can verify. Show interface IP brief. Yes, we are using 1.155 on public facing interface. Clear this NAT implementation you want?
Yes.
This command syntax is working in a real network. Now let's go to the design page. Now let's try to implement DNAT option, destination NAT, into this scenario. Let me delete this configuration. Let's go to the firewall device. Clear configure object. Clear configure NAT. Now, can we take a break for a 6 minute, everyone? 6 minute break.
Oh, yep.
It's 7:44 on my side. Okay, we can continue at 7:50. Please turn off your mic. Hi everyone, can you hear me?
Yeah, hi, hello.
Okay, let's continue our topic now. We are trying to implement destination NAT. So what is destination NAT? Remember our discussion, destination NAT, we can map multiple servers with single public IP. We can map multiple servers with single public IP. For example, in DMZ side network, I have some servers 10.1.23.15, SMTP server 10.1.20, no, 32, 32.15, 32.16, DNS server 10.1.32.17, FTP server 10.1.32.18, and for verification, I will go with DMZ router IP address. So DMG router IP address is 10.1.32.10. Okay, so this DMG router I'm using as a telnet server. This DMG I'm using as a telnet server. Telnet server. So I have single public IP. I have a single public IP 10.1.23.23.85. I have single public IP and I'm trying to map all these servers with this single public IP. Single public IP. We can go with destination NAT concept. In Cisco ASA firewall device, you can say destination NAT or you can say static PAT. Okay, this PAT is called dynamic PAT. This one is what? It's a dynamic PAT. And DNAT is called static PAT. Static PAT. So now let's try to configure destination NAT. I have single public IP. I'm trying to map all the servers with this single public IP. So let's go with the configuration command. So I'm creating object network. Command is what? Web. Object network command and object name is web. IP address for this web server 10.1.32.32.15. Into this object, I'm creating my translation entry. So traffic is traveling from DMZ to outside. I'm using static command. If you guys remember our static NAT configuration, so for static NAT configuration, we are using static command. Yes, I have a single public IP 10.1.23.85. If you press enter here, this is static NAT configuration, static NAT. But we are here to configure destination NAT. So now you can go with service command. Let's go with the text file. Let's verify command syntax first, then we can execute on firewall device. So you can use this command object network. Object name is a web server. IP address as per our design is 10.1.32.15. And yes, I have a single public IP 10.1.23.85. So now I can use service command. And now you can define TCP or UDP information. So with service, if I'm going with the question mark, I need to define TCP or UDP information. So I'm creating this entry for web services, port number 443. Web services, they are using TCP protocol. So service is TCP. Now I can define port number information, 8080 or 443. 443. So 443 and 443. So this first port number is the actual port number, and the last port number is external service port. External service port. So if anyone from outside will hit on this public IP with this external service port, we are trying to map this public IP, this external service port with this inside 10.1.23.15 with this map port number. This is command syntax, everyone. If you clear the one entry, you can create multiple. So if anyone from outside will hit on this external public IP address with this external service port number 443. So we map this public IP external service port number with this inside web server IP 10.1.32.15 port number. Actual port number is 443. So this is external service port number, and this is what internal port number. So we can define here 443. 443, its actual port number, and external service port number is 443. Done. Our first configuration, first entry for web services. For DNS, exit. For DNS object network, DNS host 10.1.32.60 NAT static command I'm using, and I have single public IP. I have single public IP 10.1.32. Sorry, 23.85 service, and DNS is using UDP protocol, service UDP. Actual port number 53, external service port number 53. Exit. We can create multiple entry. We can create entry for SMTP, for FTP. I'm creating entry for telnet now. Telnet services. So object network DMG. Now host 10.1.32.10 NAT static and public IP 10.1.23.85. Now service, and I'm looking for telnet service. So TCP, actual port number is 23 and external service port number is 23. So you can go with telnet service. If anyone from outside will hit on this public IP address with external service port number 8999, we are trying to map this public IP and this port number with this inside 10.1.32.10. This is internal port number. If you are looking for port forwarding, no problem. We can go with the port forwarding concept. Okay, for port forwarding, we can use any unregistered port number. For example, this is our telnet server 2. Telnet server 2. So I'm using external service port number 8999. 8999. Now exit. Traffic is initiated from outside. Wait. Okay, now, so traffic is initiated from outside. So to allow our traffic from lower security level to higher security level, we need to configure access list. So I'm creating access list entry, access list, outside, permit, TCP, anyone from outside can access 10.1.32.10 equal to port number 23. And this access list I can apply on public facing interface, in interface outside. Now let's try to initiate our traffic. This outside router can only hit on this public IP. Outside user, they don't know anything about inside DMZ side network. No, they can only hit on public IP. So from outside, I'm trying to initiate my telnet traffic. I'm trying to hit on 10.1.23.85. and I'm trying to initiate my traffic with default port number. With default port number, you can press enter. With default port number. Let's verify telnet configuration on DMZ router. Yes, telnet is enabled. So from outside, I'm trying to initiate telnet traffic with default port number 23, telnet 10.1.23.85. Okay, let's try again. I cannot access. Why? Because as per our configuration, our external service port number for telnet is external service port number is show run NAT. External service port number is 8999. So from outside, I'm trying to initiate my telnet traffic with port number 8999. Wait. Now port, yes, I can specify port number. Yes, you can specify port number. So port number 8999. You can press enter. See, password. Password CCIE123. CCIE123. Everyone, DMZ router. Clear this NAT implementation now. Static NAT, dynamic NAT, PAT option, and destination NAT implementation. Clear, everyone?
Yeah.
What about others? Oves, Nitish, Moin, Harshal, Dushyant, Devanshu. Clear, everyone? Okay. Now,
I have one concern.
yes, you can ask.
Can you also tell me a little bit about the pet overloading? Actually, what it is?
PAT is what? PAT, you
Put
can say
address.
PAT or you can say overload.
Okay.
You can say PAT or you can
Mhm.
say overload. It's the same
Okay.
concept.
Okay.
The
Same
same
only.
concept. Yeah, same concept.
Okay.
In
Got it.
PAT, we can translate multiple private IP address with single public IP.
Mhm.
Akash.
Okay.
Yeah.
I have also faced one kind of weird behavior actually.
Mhm.
While pet overloading, like that command inside pet, like in interface, we go and say pet overload.
Mhm.
While running that command, I face some kind of lagginess on the router. Does it's the expected behavior, or is there any memory issue which we enable pet?
No. See, it's totally depend on load. Okay, load.
Okay.
If you are using a entry-level router in a big network, yes, you
Hmm.
can face this issue.
Okay.
It's not problem of translation.
Gotcha. Thank you.
Now, so let's talk about our next topic here. Wait. Now let's talk about advanced ACL implementation. Advanced ACL implementation. This is called object group. Okay, wait. Advanced ACL implementation. Topic is object group. This is not object command. Okay, object group. So let's discuss a scenario. Okay, I have one firewall device, for example, one firewall device. And this portion is our DMZ side portion, for example. In DMZ side network, I have multiple servers, for example, web server, DNS server, SMTP server, multiple servers, okay? For example, 192, 168, 10.10. And this server is hosting multiple services. For example, this single server is hosting web services, port number 443. Okay, it's hosting port number 25, port number 21. Now we have another server 192, 168, 10.11. This server is hosting multiple services. For example, 443, port number 25, port number 21. Same 10.12, 10.13. Each server is hosting multiple services. Port number 443, 25, port number 21. This server is hosting port number 443, 25, port number 21. Now this side I'm using as a ISP side portion, ISP side network. So into this design, I have some partners from outside. For example, I have some partners from outside. For example, 99.99.99.10, 99.99.99.11.12. I have some partners from outside and I want to allow, okay, these partners, they can access these servers. So to allow our traffic from outside to DMG network, for example, from lower security level to higher security level. So I need to configure access list to allow our traffic. For example, I want to allow my traffic in between this 99.99.99.10 to 192.168.10.10. I want to create access list. What is the command syntax? Command syntax is access list. You can give access list name. For example, outside, it is a ACL name. Outside permit TCP, right? Source IP is host 99.99.99.10. Host destination IP is 192.168.10.10 equal to port number 443. This is our first entry. First entry we can create. First entry. Now I'm creating next entry, same source, same destination, but now for service 25. So access list, outside, permit, TCP, host, source, destination equal to port number 25. One more entry I'm creating in between this same source, same destination, services is 21. So access list, outside, permit, TCP, source, destination equal to port number 21. Everyone, I need to create 3 ACL entry. Yes or no? I need to create 3 ACL entry. Everyone clear my point? 3 ACL entry. Everyone, can you hear me?
Okay.
Yeah. Okay, so I need to create 3 ACL entry in between 99.99.99.10 to 192.168.10. I need to create 3 ACL entry. Now, in case if I want to allow same source IP, to access this destination server, this destination server, this destination server. So in between this source IP and this destination IP, for these services, I need 3 ACL entry. 1, 2, 3. I need 3 ACL entry. Now for this destination, 3 plus 3 plus 3 plus 3. I need total 12 ACL entry, approx. 12 ACL entry. And I have three source IP, 99.99.10.11.12. So 12 multiply 3. I need to create 36 ACL entry. I need to create 36 ACL entry into this scenario. A lots of ACL entry. I can do this, no problem. But into the scenario, we can go with advanced ACL implementation. I don't want to create 36 entry manually, one by one. Source IP, destination IP, services. Next entry, source IP, destination IP, services. No. Into this big scenario, we can go with advanced ACL implementation object group concept. Object group. In object group, what we can do? In object group, we can create object here. Let me show you. Wait. So into the scenario, I will create object here, object group here. For example, I'm creating object group. It's called partners. It's object group name. And into this group name, I have all source IP information. For example, 99.99.99.10.11.12.13. I will create one more object group. It's called servers. Servers object group name. Here I can put all my inside server IP address. 192.168.10.10, 10.11, 10.12, 10.13. So 192.168, 10.10, 10.11, 10.12, 10.13. I will create one more object group. It's called services. Services, it's object group name, everyone. Services is an object group name. You can type anything, no problem. You can type SRV, for example. So I'm creating services object. Services object. Into the services object group, I will put all the services. For example, port number 443, 25, 21, 23. So what I will do, I will create object group here. And these object group, I will apply in access list. When I apply these object group in access list, firewall will create all ACL entry automatically. Firewall will create all the ACL entry automatically. Let me show you with practical example. Okay, wait. For example, see, here we have some server this side, and we have some partners from outside. We have some partners 10.1.23.15, 10.1.23.16, 23.17, 23.18, and for real verification 10.1.23.10 outside router IP address. So I have some partners from outside. I have some server in DMZ side network. I have services information. I have services information. Let's create object group here. Wait. Let's go to the firewall device. Okay, I think I need to delete all translation entry. Wait. Clear configure object. Clear configure access list. Let me check. Show run object. Show run NAT. NAT. Okay, show run access list. Okay, so we don't have any NAT translation entry and ACL entry. Now, you can also verify show access list command. We don't have any ACL entry right now. So now I'm creating object group here. I'm creating object group. How to create object group? Command is what? Object group. Okay, object group. Now you can type question mark. So you can create network object group. You can create services object group. So right now I'm creating network object group. So network command, you can give a name for this object group. For example, I'm giving name PN partners, for example. Into this object group, I can define all partners IP address information. So command syntax is, wait, network object. Now question mark host. So host is 10.1.23.15. Host is 16. Host is 17, 18. And for real verification, .10. Exit. Now object group network, and I'm creating one more object group, servers. Name is what? Servers. Servers. Now network object host. So 10.1.32.15, 16, 17, 18, and for real verification, I'm using 32.10. Now exit. Now object group network, and I'm creating. Now this time I'm not using network. No. This time I'm not using network command. This time I'm creating services object group. Services object group, TCP and UDP services object group. So services, service, question mark. You can give a name for this object. So I'm using SRV. It's object group name. Question mark. You need to define TCP traffic, TCP services information, UDP services information, or TCP and UDP combination. So I'm using TCP, all TCP services. Now question, enter. Here we can use port object command. In network, we can use network object. In services, we can use port object equal to port number 443, equal to port number 25, equal to port number 21. And for real verification, I'm using port number 20. So we have object group here. Let's verify, show, run object group. So we have partners. We have servers object group. We have services object group. Now I'm creating access list. Access list outside permit TCP. Now question mark. This time I'm not using source information. No. This time I'm using object group command. And you can verify now object group for source address. Object group you can define for source address. As per our task, traffic is initiated from outside network. So our source is partners. So object group and object group name is partner. Now question mark. Again, we are using object group, and this time object group for destination address. So object group. So destination is what? Servers. Now again, object group, question mark. Right. Question mark. So this time again, we have object group, but this time object group for destination port number. So object group and services name is SRV, I think. SRV. Now we can apply. Done. You can apply this access list. So access group outside, in interface outside. So we can try to initiate our traffic from outside, no problem, but let's verify access list entry. As I said, it will automatically create all ACL entry. Let's verify this time. Show access list. And yes, I have multiple access list entry. Everyone clear? Akash, Devanshu, Dushyant, Harshal, Moin, Pratish, Wes. And you can verify. Okay, let's go to outside router. And as per our this last entry, this 10.1. This 10.1.23.10 can access 10.1.32.10 for telnet service. So let's try now from outside telnet. 10 dot, 1 dot, 23 dot, 10, and yeah, no, sorry, it's a 23 dot, it's a 32 dot 10, 32 dot 10. Yes, password we are using CCIE 123, CCIE 123. Yes. So this is our topic. What? This is our topic, object group. Object group. Now we can discuss IPv6 routing. Before discuss IPv6 routing, let's talk about layer 2 firewall implementation. Into the same design, we can discuss layer 2 firewall implementation. Can we take a break for 7 minutes, everyone?
Okay.
Let's take a break for 8 minutes, okay? It's a 8:22 on my side. We will continue at 8:30, okay? Please turn off your mic. Hi everyone, can you hear me? Everyone, can you hear me? Can we start our topic now? Can we continue? Akash, Devanshu, Dushyant, Harshal, Moin, Nitish, Umesh. Can we start our discussion? Okay.
Yes, sure.
Yes.
Okay, now let's talk about our next topic is called transparent firewall device, layer 2 firewall implementation. Okay, so we can use our firewall device in two mode. Either we can use our firewall box as a layer 3 firewall box. We can use our firewall box as a layer 3 firewall box, or you can say NAT mode firewall. NAT mode firewall. This is the first option. Second, we can use our firewall box, complete box, as a layer 2 firewall, or you can say transparent firewall device. Okay, I have a firewall box, and this box, for example, I'm using as a layer 3 appliance, as a layer 3 firewall box. So these interfaces are like router interfaces. We can configure IP address on these interfaces. It's a L3 interface, everyone. We can configure IP address on these interfaces. We can configure routing into this box, routing, NAT we can configure, VPN we can configure, and we can also utilize firewall feature here. But in case, if you are using this complete box as a layer 2 firewall or as a transparent firewall device, so these interfaces are called L2 interfaces. I'm not talking about switch port, okay? These are L2 interfaces. It means we cannot configure IP address on these interfaces. We cannot configure routing. We cannot configure routing here. NAT, no. VPN, no. But you can utilize firewall feature. You can utilize firewall feature here. So what is the scenario to use our firewall device as a layer 2 firewall box? Because we have a limitation. With layer 2 firewall box, we have limitation. If I'm using this complete box as a layer 3 firewall box, yes, I have great feature. I can connect my firewall device with internet directly. I can configure translation rule. I can terminate VPN connections. But with layer 2 firewall box, we have limitation. Okay, so what is the scenario to use our box as our Cisco ASA firewall box as a layer 2 firewall box? Let's talk about design. Okay, I'm working in an existing routing switching topology. For example, I have a router. This router device is connected with ISP side portion. This is ISP side network. And this portion we are using as a LAN side portion, inside network, LAN side portion. Into this design, everything is working fine. Okay, this machine can initiate its traffic. Okay, this traffic will go and hit on switch. Switch is forwarding traffic to the router. And based on routing table, the router is forwarding traffic to the outside. Everything is working fine into this design. And this portion is your LAN subnet, LAN side network. This portion is your WAN side network. So into this existing design, now you want to deploy a firewall box here into this existing design. You want to filter your traffic now. You want to deploy a firewall box. So if I'm trying to deploy my firewall box here in inline mode, I'm trying to deploy a firewall box here. And this box I'm using as a layer 3 firewall. This box I'm using as a layer 3 firewall box. So these interfaces are called L3 interfaces. These interfaces are L3 interfaces. Each interface will participate in different subnet, just like a router. So if you are trying to deploy your firewall box into this existing design, so you need to change your existing IP address scheme, your single subnet. Now your single subnet is divided into two different subnet. This portion is your different network. This portion is your different network. If you want to deploy your firewall box as a layer 3 into the scenario, no problem. You can deploy as a layer 3. You can configure IP address. You can change your existing IP address scheme and you can deploy, no problem. But in case, if you don't want to change, anything, any IP address scheme into this live network, I don't want to change any IP address scheme and I want to deploy a complete firewall box. So I can use this firewall box as a transparent firewall device. If this box I'm using as a layer 2 firewall box, if I'm using this box as a layer 2 firewall box, so these two interfaces are Alto interfaces. No need to configure IP address on these interfaces. So again, you are in same subnet. But yes, it's a firewall box, so you can give a name, you can give a description. For example, this one is your inside interface. This one is your outside interface. And it's a Cisco ASA firewall device. So traffic is allowed from higher security level to lower security level, and only TCP and UDP traffic. So we can deploy our layer 2 firewall box in an existing scenario. In a live network, I can deploy my firewall box as a layer 2 firewall box where I don't want to change any IP address scheme. Clear this point, everyone? Clear now? No. So I have a layer 2 firewall box. Okay, I have a layer 2 firewall box. I told you, you cannot configure IP address on any interface. This is a layer 2 firewall box. Transparent firewall device. I cannot configure IP address on any interface, on any data interface. No. So in case, if I want to access this firewall box from this management PC, for example, in case I want to access this firewall device, this layer 2 firewall box from this management PC, yes, I can connect cable, no problem. I can connect my cable with a fast Ethernet 0/0, for example. I want to access this layer 2 firewall box through Telnet or through SSH or through HTTPS graphical page. I want to access. So for HTTPS, for Telnet, for SSH, we need device IP address. We need device IP address, and we cannot configure IP address on any interface. Then how we can access this firewall device? So if you remember your basic CCNA topic, if I have a layer 2 switch, for example, if I have a layer 2 switch and I want to access this layer 2 switch from this management PC, this management PC, for example, is connected with a switch fast Ethernet 0/22 interface. So I want to access this layer 2 switch from this management PC through Telnet, for example, through Telnet. So what we can do here into the scenario, we can configure IP address on VLAN interface. Remember, everyone, in layer 2 switch, we can configure IP address on VLAN because by default, VLAN 1 is a management VLAN. Everyone remember CCNA training?
Yes.
We can configure IP address on VLAN.
Yeah.
VLAN 1. VLAN 1 is a default VLAN. VLAN 1 is a management VLAN. So we can configure IP address on VLAN 1. And all interfaces, they are the part of, by default, they are the part of VLAN 1. So we can configure in layer 2 switch. We cannot configure IP address on any interface. Not possible. It's a layer 2 port, switch port. So we can configure IP address on VLAN interface, VLAN. For example, I'm using 192.168.10.10.1, same series of IP I can configure here, 192.168.10.10, and I can access. Same concept we have in Cisco ASA firewall device. Same type of concept. In Cisco ASA firewall device, we have bridge group concept. Bridge group. Bridge group. Bridge group interface. In layer 2 switch scenario, you have VLAN interface. In layer 2 firewall scenario, in Cisco ASA firewall box, we have bridge group interface. So we can configure IP address. We can configure IP address on bridge group interface. Let me show you it. So I have simple design. Wait. So into this design, this R4 is a public facing router. R4 is a public facing router. Public facing router. And this portion we are using as a inside LAN portion. Inside LAN portion. So this is 200.200.200.0. Let's go to firewall box first. Firewall box, and you can verify. Show firewall command. You can verify your firewall mode. So this firewall mode is right now router mode. If you want to change this firewall mode, you can go with firewall transparent command. You can use this command to change your firewall mode. Firewall transparent. You can press enter. You can press enter. It will automatically erase all the configuration. See, it will automatically erase all the configuration. If you verify, show interface IP brief, no. If you go with show run interface command, now we cannot configure IP address on any interface. IP address command is not available. If you go and verify, if you check, for example, interface Ethernet 0, name if inside. Now IP address, I'm looking for IP address configuration. I cannot configure. I cannot configure IP address on these interfaces. So now let's try to configure Cisco ASA firewall device inside interface. Ethernet 0 we are using as a inside interface. And now I'm using a command, bridge group. I'm trying to put both the interfaces, Ethernet 0 and Ethernet 1, in bridge group. So you can create bridge group number in between 1 to 100, and I'm creating bridge group 1, just like a VLAN everyone. Ethernet 0 I'm using in bridge group 1, Ethernet 1 I'm using in bridge group 1. Now no shutdown, exit. Let's go to Ethernet 1. Name if outside, bridge group 1, no shutdown. Now you can verify, show, run, show interface IP brief. We have two interfaces, Ethernet 0 and Ethernet 1. Now I'm giving IP address to bridge group. So we are using bridge group 1. What is command syntax? Interface, and we have a command. What? BVI interface, bridge group virtual interface. So I'm using BVI interface. BVI interface number is 1. Now I can configure IP address. So 200.254 mask. Done. Exit. And if you check your interface information, so we have same IP. We have same IP on all interfaces. So this firewall IP is now, this complete firewall IP address is now 200.200.200.254. You can connect your management port. For example, you can connect your management port with this interface, your management PC. And for this management PC, this complete firewall IP address is 200.200.200.254. Now let's go to inside router. Let's go to inside router. And I'm trying to verify IP address configuration. Show IP interface brief. Yes, 200.200.200.10. Let's go to outside router. And I'm trying to configure same subnet of IP. Ethernet 0/1 is a LAN facing interface. So interface Ethernet 0/1. 200.200.200.15 mask. No shutdown. Show IP interface brief. You can verify now. 200.200.200.15. Same subnet of IP I'm using. Same subnet of IP I'm using here. 200.200.200.15. So from this inside machine, I'm trying to initiate my traffic. I'm trying to travel through the firewall device. And this firewall box we are using as a transparent firewall device. We cannot configure IP address on any interface. We cannot configure routing and NAT, no. VPN, no. Let's try to initiate our traffic. I'm trying to access telnet service. 10.1. 200.200.200.15. So from this inside machine, we are trying to access this gateway IP. So traffic we are initiating from higher security level to lower security level. And yes, we can access. See, we can access Cisco 123. We can access. So it's a firewall box. It's a Cisco ASA firewall box. So we have the same concept. Traffic is traveling from higher security level to lower security level. If you want to allow traffic from lower to higher, no problem. It's a firewall box. It's a firewall box. You need to configure access list. It's a complete Cisco ASA firewall box, everyone. Now we have limitation. What limitation? We cannot configure IP address on any interface. Routing, no. VPN, no. NAT, no. But it's a firewall box. To allow traffic from lower security level to higher security level, you can configure ACL rule here. For example, if I'm trying to initiate my traffic from outside, let's try to initiate our traffic. Let me check telnet configuration. Wait. Telnet password on R1. Okay, telnet is not enabled. Wait. Line VTY024 password CCNP123 login transport input telnet. Let's go to outside router. And from outside router, I'm trying to initiate my traffic. 200.200.200.10. And I cannot access because we are trying to initiate our traffic from lower security level to higher security level. Traffic is not traveling. Let's go to Cisco ASA firewall box. And I'm creating access list entry to allow our traffic. Access list outside format TCP source 200.200.200.15 destination 200.200.200.10. And yes, we can apply access list outside in interface. Oh, sorry, access group command. Outside in interface outside. Now you can try to initiate your traffic. Let's try to initiate our traffic from outside 200.200.10. And yes, I can access password we are using CCNP 123. Wait, CCNP 123. Yes. Clear this implementation, everyone.
Yeah.
Now let's talk about some other points in transparent firewall device. Our next topic is multicast through transparent firewall box. Multicast routing through transparent firewall device. So what I'm doing, I'm trying to create loopback interface here, okay? 1.1, 1.1.1, and one loopback interface here, for example, 3.3.3. This is same subnet. So now I'm trying to create a loopback interface on router 2. I think we have a loopback. Wait, show interface IP brief. No, sure. Show IP interface brief. Yes. So I'm using any dynamic routing protocol here, everyone. Any dynamic routing protocol. I'm trying to verify multicast traffic through transparent firewall device. So now I'm trying to configure dynamic routing protocol, okay, on inside router, on outside router. So now I'm using EIGRP, for example, router, EIGRP 10. Let's advertise our network 200.200.200.0, wildcard mask, network 1.1.1.1, wildcard mask, no auto summary. Let's go to outside router. Now router, EIGRP 10, network 200.200.200.0, wildcard mask, and loopback 3.3.3.3, wildcard mask. No auto summary. So this is directly connected. This is directly connected, you can see. Logically, they are directly connected. This firewall box we are using as a transparent firewall device. I'm using 200.200.200.10, 200.200.200.15. So I'm using dynamic routing protocol here on R2 and on R4. Dynamic routing protocol. Let's verify our neighbor table information. Show IP EIGRP neighbor. I don't have any neighbor entry. Show IP EIGRP neighbor. I'm not receiving any neighbor information. Why? Because by default, multicast traffic is not allowed through transparent firewall device. This is our topic. Okay, you are working in a scenario where you have where you are using routing concept, okay, and you have a transparent firewall device. If traffic is not traveling, multicast traffic is not traveling through the firewall device, you need to check your firewall mode. The firewall mode is layer 2 firewall box mode, transparent firewall box mode. So you need to know the concept, default concept. By default, multicast traffic is not allowed through transparent firewall device. By default, see. So to allow our traffic, multicast traffic through transparent firewall device, we need to configure access list here. We need to configure access list. For example, let's go to the firewall device. Let me delete this access list entry. Clear configure access list. So now I'm creating access list entry to allow my multicast traffic. So access list, for example, outside one, permit, TCP, no, EIGR, permit, EIGR. EIGRP is not using TCP or UDP. Remember everyone, basic routing concept. EIGRP is not using TCP or UDP. EIGRP, using RTP protocol, Reliable Transport Protocol. So permit EIGRP. Now you can define your source. So for source and destination, I'm using any source, any destination. Otherwise, no problem. You can define it. Okay now. So you can define your source information, access list outside, permit EIGRP. This source can exchange multicast traffic with this multicast group. This is multicast address in EIGRP protocol 224.0.0.10. If you go with RIP protocol 224.0.0.9. If you go with OSP of 224.0.0.5 and 6. So this is EIGRP multicast address. So with this ACL rule, we are trying to allow this host can exchange multicast update with this multicast group. You can define your source IP, destination IP for multicast traffic, EIGRP packet, or you can go with any. Okay, let's go with the any. Wait. Let's go with the any source, any destination. And once you configure access list, you need to apply on interface. So access list, access group, outside -1. Wait. Outside -1 in interface. And I want to apply on outside interface first. Wait. I want to apply on outside interface first. When you apply, wait.
The spelling is
Oh,
not.
sorry. Outside. When you apply this, you can verify now. You can verify on R2 router. See, R2 has a neighbor relationship with outside router. So you can check now neighbor table. Yes, you have neighbor table. But if you go and check on outside router, you don't have neighbor information. You don't have neighbor information. So you need to apply this access list on both interfaces. So outside, and I want to apply on inside. When you press enter, you can see now, wait. See, neighbor relationship, new agencies. You can verify now, show IP EIGRP neighbor. You can verify now, show IP route. So now multicast traffic is traveling through transparent firewall device. Like this, you can allow OSP of multicast address. You can allow RIP multicast address. So this is the topic. Routing through transparent firewall device. Multicast traffic through transparent firewall device. Clear this point in transparent firewall box. Clear this point, everyone.
Yeah.
Multicast traffic through transparent firewall device. Let's talk about one more point. One more point in transparent firewall box. Ether type ACL. Let's talk about it. Ether type ACL. What is ether type ACL? Ether type ACL. So by default, only IP packet. By default, only IP packet is allowed through transparent firewall device. Only IP packet. Non-IP based traffic is not allowed through transparent firewall device. Any idea about non-IP based traffic? Everyone? Any idea about non-IP based traffic? Remember MPLS technology? MPLS, it's a non-IP based traffic. Remember MPLS, frame relay? Frame relay is an old technology, but it's a non-IP based traffic. So MPLS is example, frame relay is example. In MPLS, what we have? In MPLS, we have labels. In MPLS cloud, wait. In MPLS cloud, what you have? This is MPLS cloud. This is your customer edge router. This is your customer edge router. So customer edge router, ISP can connect with P router, right? Provider edge router. Customer router, ISP can add. In MPLS cloud, can add with P router, provider edge router. Provider edge router. So from customer to provider edge router, this is IP packet. Yes, this is IP packet. From customer to provider edge router, this is IP packet. But in MPLS cloud, here we have what? P routers, provider routers, P routers. We have provider routers. In MPLS cloud, we have only labels. In MPLS cloud, what we have? Labels. So in MPLS cloud, we have non-IP based traffic. In MPLS cloud, we have non-IP based traffic. MPLS is example. Frame relay technology, it's an example. It's a non-IP based traffic. My point is, if you are working in any non-IP based, if you are working with any non-IP based traffic, okay, you are using transparent firewall device. And if traffic is not traveling, any non-IP based traffic not traveling through the transparent firewall device, that's why you need to configure ether type ACL. Non-IP based traffic is not allowed by default. Non-IP based traffic is not allowed through transparent firewall device. Only IP packet. Only IP packet, because IP packet ether type is 0x0800. If you remember OSI model in CCNA training or TCP header, TCP UDP header, IP header. So this is what? Ether type. Ether type works on OSI model data link layer. It is in between data link layer and network layer. Ether type value. So this is IP packet. If you check your IP packet ether type number, so ether type value is 0x0800. So only this ether type value is allowed by default through transparent firewall device. But non-IP based traffic is not allowed through transparent firewall device. For example, MPLS is not allowed. MPLS traffic is not allowed through transparent firewall device. So to allow MPLS traffic through transparent firewall device, you can configure ether type ACL. Ether type ACL. Okay, here we are not using any MPLS cloud. Okay, here I'm telling you, I'm trying to show you command syntax here, how to configure ether type. For example, I have a rule access list. You can give access list name. Ether type is a command, permit, and this ether type 0x8847 into this notepad file. This ether type value is a MPLS technology ether type value. You can check with Google, no problem. Wait. Ether type. So IP packet ether type is 0x0800, and I'm looking for MPLS 0x8847. So in case if you want to allow non-IP based traffic through transparent firewall device, you can configure ether type ACL. Let me show you command syntax. Command syntax is what? Access list. Access list, you can give any name, for example, ABC. Now question mark. This time I'm using what? Ether type. And you can see configure access policy for non-IP traffic through the system when configured in transparent mode. So ether type. Now question mark. You can decide deny or permit. I want to permit. Now you can type ether type value. For example, MPLS I want to allow. What is ether type value? Value for MPLS 0x8847. And once you configure your ether type, you need to apply on interfaces. So I'm trying to apply access group ABC in interface outside inside. Done. This is ether type ACL configuration. And this is our topic, transparent firewall device, layer 2 firewall implementation. I hope it's clear, everyone. Now let's talk about IPv6, next generation IP configuration, IPv6. So remember in IPv6 format, everyone, IPv6 format, IPv6 has 100, wait, IPv6 has 128 bit. And what is IPv6 format? Hexadecimal format. And yes, we have example. We have example for IPv6. 2001:10:1:12:1/64. This is IPv6 IP. Remember, in CCNA training, this is IPv6 IP. How to configure IPv6? Next generation IP, yes. Like other firewall device, you can configure next generation IP in Cisco ASA firewall box. Let's go to the interface. Show interface IP brief. If you are familiar with IP version 6 concept, you can configure in any firewall box. Okay, so show interface. No, show IPv6 interface brief. So I don't have any IP address, IPv6 address. Let's try to configure on Ethernet 3, for example, IPv6 address. We have same command syntax, just like a Cisco router, same command syntax. IPv6 address. IP 2001:10:1:12:1/64. Done. Okay, wait. 2001:10:1:12:1/64. IPv6 address. Two 2001:10:1:12:1. What happened with this IP? Wait, everyone. show IPv6 interface brief. Okay, interface Ethernet 3 IPv6 address. Two thousand one colon 10 colon 1 colon 45 colon 1/64. Invalid input. Okay, no problem. Let's try with any other firewall device. This is CISCO ASAP. Wait. This will take time. Can we take a break for 5 minutes only? Everyone, only 5 minute break.
Sure.
It's a 9:10. We will continue at 9:15. Okay, please turn off your mic.
I
Okay.
have one.
Yes, Akash. Any question?
Yep, I'm just thinking about that IPv6 invalid. Is it because that firewall is in transferred mode?
Okay. Thank you so much. Okay. This is layer 3, layer 2 firewall box.
Yeah.
Thank you. Firewall, transparent. Yes, thank you. Show firewall. Yes, now I can configure. Okay, let's go to interface. Any interface, Ethernet 3, IPv6 address 2008. 2001 colon 10 colon 1 colon 12 colon 1/64. No shutdown. Now show IPv6 interface brief. Yes, we have this IP address. In case if you are looking for IPv6 routing, IPv6 router question mark, and you can configure only OSPF. See, with this firewall image, you can only configure OSPF. Let's try with this latest OS version 9.7. It's taking time. Okay, let's try with the latest ASA image 9.7. With this 9.1, we can only implement OSPF, IPv6 router OSPF. Let's verify with 9.7 image. Okay, now let's verify everyone. This is show version. This is 9.9.7. 7 OS version. So we can try here. IPv6 router, question mark, you can only configure OSPF. So if you are working with IP version 6, if you are trying to configure IP version 6 routing, in dynamic routing, you can only configure OSPF. RIP and AIGRP option is not available. Clear this task. Clear this task, everyone. I'm not configuring OSPF. I'm only giving you an idea. Yes. So this is our topic. This is our topic, IP version 6, next generation IP address configuration. And in case if you want to configure IPv6 routing, you can configure static routing, you can configure dynamic, and in dynamic, you can go with OSPF protocol only. Now we can focus on logical interfaces. With these two topics, we can finish our today's session, okay? How to configure red interface, how to configure port channel. Now let's take a break for 5 minutes. Everyone, 5-minute break, okay? We will continue at 9:21. Please turn off.
Okay.
Hi everyone, can you hear me? Akash, Devanshu, Dushyant,
Yes, we
Harshad,
can
Yep.
hear you.
Natish, Oves. Okay, let's continue our topic now. So now we are trying to focus on how to create logical interfaces. Logical interfaces. We have two options for logical interfaces. We have two options. We can create red interface. We can create port channel. Remember port channel or ether channel concept from CCNA training? Can anyone help me? What is port channel, everyone? Or ether channel? Remember port channel? We can aggregate the bandwidth of link, right? For example, we have multiple interfaces. We have multiple interfaces. For example, this is fast Ethernet 0/0, 0/1, 0/2. Okay, and we have 1 Gbps speed with each interfaces. 1 Gbps, 1 Gbps, 1 Gbps speed. In port channel or in ether channel, we can aggregate the bandwidth of these three interfaces and can create a logical interface. We can create a yes.
Is it like bundle related to bundle or something? I
Yes,
heard,
yes.
right?
Yes,
Uh,
I'm talking about
right.
bundling. I'm
Bundling,
talking
correct,
about
correct.
port channel.
Port channel.
The channel,
Okay, fair.
port channel, it's a bundling, yes.
Right.
In
Thanks.
CCNA training, you can say ether channel. In Cisco ASA firewall box, it's a port channel concept. Okay. We are trying to aggregate the bandwidth of these interfaces. We can create a single logical port. We can create a single logical port. It's called port channel. You can say port channel or ether channel. So for example, I'm creating port channel. Now the single interface, this single fit, this single interface speed is what now? 3 Gbps. 3 Gbps. We can aggregate the bandwidth of these three interfaces. 3 Gbps speed we have with port channel interface. If you remember CCNA training, so in port channel, in ether channel, we have two protocols, PAGP and LSCP. LSCP protocol. PAGP is a Cisco standard protocol and LSCP is an open standard protocol. LSCP is a popular option because PAGP we can only use in a Cisco scenario. In case if you have Cisco device and Juniper device and you want to establish your ether channel, then you can go with LSCP protocol. This is open standard protocol. And Cisco ASA firewall device only support LSCP. You can check now. With command sentence, you can verify. Cisco ASA firewall device is only using LSCP protocol. In LSCP, we have mode, active and passive mode. Passive mode. So you can aggregate the bandwidth of these three interfaces and can create a logical port, single logical port with 3 Gbps speed. This is called ether channel or port channel. And it's a L3 ether channel. So we can configure IP address on port channel interface. We have one more option. We have one more option here. It's called red interface. Red interface. Redundant interface. So what is a red interface? What is a red interface scenario? So let's talk about scenario first. Wait. Let's talk about scenario first. So I have one interface, for example, one interface, port fast Ethernet 0/7. I have one interface. This interface is connected with a LAN switch, and in LAN side portion, we have multiple computers. We have proper IP address configuration on port number 7. Proper configuration, proper interface configuration we have. Now, in case if this interface goes down, in case if this interface is not working, so what you can do in a real network? In a real network, if this interface is not working, maybe some problem. This interface is not working. What you can do in a real network, you can unplug this cable You can unplug this cable and you can plug this cable to any other interface. For example, fast Ethernet 0/8. And you can configure same configuration on port number 8. But this is manual task. If port number 7 is not working, you can manually unplug the cable, plug to port number fast Ethernet 0/8. Then you can configure IP address. This is manual task. And I don't want to do manual tasks. I'm looking for a dynamic option. So what we can do, we can combine these two interfaces. We can combine these two interfaces. For example, I have one more interface. I have one more interface. One more interface, fast Ethernet 0/8. One more interface, 0/8 interface. I can combine these two interfaces. I can combine these two interfaces and can create a single logical port. Is called the red interface. We are here we are not aggregating bandwidth of these links. No. In port channel, you can aggregate the bandwidth of these three interfaces. You can create a single logical port with 3 Gbps speed. But in red interface, we are not aggregating bandwidth. No. You can combine two interfaces, only two interfaces. You can combine two interfaces and can create a red interface. This is called interface level redundancy. When you combine these two interfaces, one interface will act as an active port, one interface will act as a passive. And when you combine these two interfaces, you can create a red interface. For example, red 1. This interface name is what? Red 1. I can configure IP address on this red interface 192.168.10.1. And this 10.1 is acting as a default gateway for all LAN machine. So when you combine these two interfaces, you can create a single logical port. And when you combine, one interface will act as an active, next interface will act as a passive. All the traffic will process through active port. If active port goes down, no problem. This passive interface will become active and traffic is processing through this interface. Clear my point? This red interface, everyone?
I have one question.
Sure, you can ask.
Okay, does it monitor the link state, or is any kind of ping or anything is there to monitor like the status of interface?
See, it's
How
a
actually?
combination. It's a combination. When one interface goes down, automatically second interface will become active automatically.
Suppose I'm just thinking one scenario where the links are up, okay, but somehow the traffics are not flowing. So does it?
No, we cannot use this type of monitoring. No.
Okay, got
If
it.
one interface is not working properly, the second interface will take the responsibility.
Okay, for completely down status.
Yes.
Okay.
Now
got
let's
it.
try to configure it. Let's try to configure port channel and red interface. Wait. Let's try with this firewall device. Please wait. Okay, everyone, can you hear me? Okay, let's try to configure red interface and port channel. For port channel, I'm using Ethernet 0 and Ethernet 1. Ethernet 0 and Ethernet 1. So you can go to interface Ethernet 0. You can type question mark. You can use this command channel group. You can use this command channel group. So channel group. You can create 1 to 48 channel group. I'm creating first one, question mark, mode, question mark. We are getting active and passive. As I said, Cisco ASA firewall device is only using LSCP protocol. It's an open standard protocol for Ether channel, for port channel. And in LSCP, we have two modes, active, passive. What is the successful combination? What is successful combination? For example, I have a firewall box, and this firewall device is connected with a switch or L3 router, for example, router. Both the devices are L3 devices, and I'm creating L3 Ether channel. So I'm trying to combine these two interfaces. I can create a single logical port. Same task I will do on other side, on this side, because for Ether channel, you need to configure Ether channel negotiation protocol on both the sides. And what is successful combination? Let me show you. What is successful combination for to form Ether channel? Okay, so this one is a successful combination for to form Ether channel. Okay, one side if you have active mode, and on other side you have active mode, you can form Ether channel. On one side you have active, and on other side you have passive. Yes, you can form Ether channel, but on both sides you are using mode passive, you cannot form Ether channel. This is successful combination to form Ether channel. So now mode I'm using what? Active, for example, active. Now exit. Let's go to Ethernet 1, channel group 1, mode active. So on other side I will use passive. So now you can verify. You can verify now. Show interface IP brief. Show interface IP brief. So we have port channel. Right now, port channel status is down because you need to configure port channel configuration on other side. That's why status is what? Down. Line protocol is what? Down. Now it's a L3 Ether channel, so we can configure IP address. Interface port channel 1. Interface port channel 1. IP address, for example, 50.50.50.1 mask. Now you can verify show interface IP brief. Wait. Okay, I need to go on port channel again, and we can use a command name if. So this interface is a part of inside network. Now you can verify show interface IP brief. So you can check IP address information. Clear how to create port channel, everyone? Clear how to create port channel?
Yeah.
Okay, how to create red interface? So we have two interface for red interface configuration, Ethernet 2 and Ethernet 3. So interface Ethernet 2, no shutdown. Ethernet 3, no shutdown. So now we have a command interface. We have a command interface, what? Red interface. Red interface. Yes, we can select a number in between 1 to 8. For example, I'm creating my first red interface. Here I can type a command member interface. Member interface. My first member interface is Ethernet 2. Now member interface Ethernet 3. Now I can define name if for example DMG security level 50 and IP address I can configure. For example, 40.40.40.1 mask. Now exit, show interface IP brief. So you have a red interface, and this red interface status is up. Why? Because no need to configure red interface on a router and switch. It's not a router or switch concept, it's a firewall concept. Same concept you can configure in Cisco FTD, Cisco next generation firewall device. We have same topic, red interface. And if you want to verify red interface information, show interface redundant 1. So yes, we have 2 interfaces. You can check now. Ethernet 2 is the active port. Ethernet 3 is a passive port. Standby port. Standby port. In case Ethernet 2 goes down. Okay, let's verify this information first. So this is red 1 interface. It's a part of DMZ. DMZ line protocol is up. This is a red interface. This is red interface MAC address. This is red interface MAC address. So this one is your port number 2 MAC address information. Let me show you. Wait. Show interface Ethernet 2. You can verify now. 0002. You can verify here 0002. So it's an active port MAC address. This port number 2 MAC address is now assigned to this red interface MAC address. Now you can verify again. Ethernet 2 is an active port. Ethernet 3 is a passive port. In case if Ethernet 2 port is shut down, Ethernet 2 port is not working. So in case if you verify this time, automatically port number 3 is in active state. And after some time, if Ethernet 2 will come up again, Ethernet 2 no shutdown. So it's not like a preemption technique. No. Ethernet 2 status is what? Passive status. You can verify Ethernet 3. Ethernet 3 is what? It's an active port. Now when Ethernet 3 goes down, then Ethernet 2 will become active. Clear this point, everyone? Now this is our topic. Red interface and port channel. Now let's continue our topic in next session, everyone. Same time. Akash, Divyanshu, Dushyant, Harshal, Nitish, Wes. Virtual firewall.
Yep, sure.
Security context. Failover concept. Okay, how to access firewall box with graphical page. These points we can discuss. In next session. Bye guys. Take care. Good night, everyone.
Bye.
Bye. Good night, everyone.
Good night.